So I'm going to explain some of the basics of machine learning through a set of straight lines and very simple figures which don't have a lot of text, but I'm going to talk and give you the intuition behind how things work. So let me get started. And by the way, I might make a lot of mistakes when I'm speaking, not mistakes on the concept, but mistakes about how I'm presenting. So please overlook that. Okay, let me get started. Here we have the vertical axis and the horizontal axis, and a line which passes through the origin at an angle of 45 degrees. A rather innocent looking system, but it has got a lot of mysteries hidden behind it, which we'll come across soon. Here I've drawn a vertical line at any random point on this 45 degrees line. Now this triangle that is formed because of that is kind of important, kind of interesting. Because it's at 45 degrees, this length is going to be the same as this length. This is actually nothing but the y-intercept of this point, which is going to be here. So that length is the same as this length, and this length is the length of the x-intercept of this point. And since it's at 45 degrees, it's kind of symmetric to both y and x axis, and so the y-intercept and the x-intercept are going to be the same. So that's why this length and this length are the same. Now this triangle is really important, and that's why I have dedicated an entire page to this. Here if you see this triangle, if I slide it up and down this line, it's not going to make a big difference. It's not going to actually change anything about this triangle. It's not going to change the lengths of these vertical and the horizontal lines. And also, if I change the size of that triangle, make it smaller, that is definitely going to change the length of these, but that's not going to change the kind of properties of that triangle. If you think about it, if this length is the same as this length, then this tiny triangle, which is just a compressed version of this length is also going to be the same as that length. So no matter where I slide this triangle, or whether I compress it or expand it, its basic properties are going to remain the same. Now let's do something interesting. Let's rotate this line, and let's see how that triangle is affected when you rotate that line. As you can very clearly see, if you rotate that line from 45 degrees towards 90 degrees, the vertical of the triangle is going to increase in length and the horizontal is going to reduce, until at 90 degrees the horizontal is going to be actually 0 and the vertical is going to be a finite length. Similarly, if you push it down, then the horizontal is going to increase and the vertical is going to reduce. And if you make it completely horizontal, the vertical is non-existent and the horizontal is a finite length. There are few interesting things about what I just said. Let me list them one by one. First of all, when the line is at 45 degrees, this is the same as this, and that's why the ratio of this by this is going to be 1. When the line is slightly greater than 45 degrees, this is going to be greater than this. That's why the ratio of this by this is going to be greater than 1. When the line is less than 45 degrees, the ratio of this by this is going to be less than 1. When the line is horizontal, the ratio is going to be 0, because it is 0 by something is going to be 0. And similarly, when the line is completely vertical, the ratio is going to be infinite, because this divided by this is going to be infinity. The second important thing about this figure is that the ratio that I was talking about, y by x, is called multiple things. It has multiple names. One name is the slope. So we say that the slope of this line is, in this case, 1, because this divided by this is 1. The slope of this line is greater than 1, because this divided by this is greater than 1. The slope of this line is infinity, and the slope of this line is 0. The slope of this line is less than 1, and so on. And that makes sense, right? Because this line is horizontal, so there is no slope, and this line is, as it increases in slope and finally reaches vertical, it has got infinite slope. So that makes sense. And now the third important thing about this figure is that this ratio is actually determining how many times y is as compared to x, right? Obviously, right? Here y is the same as x. Here y is these many times the ratio number of times greater than x. So if let's say y is 2 and x is 1, then y is 2 times x. So the ratio of y by x is 2, and y equals that ratio multiplied by x. Similarly, if y is 1 and x is 2 here, then y is half of 2, right? So the ratio of this by this is half, and that's why y is half of x. And what I just said, y being half of x, or y being equal to x, or y being twice of x, is actually defining the line itself. That is the definition of line, because there's nothing more to the line that needs to be defined. That is what actually completely defines a line in this case. Here y equals 0 times x, that is y equals 0. That is true, that y actually line goes through the origin. Here y equals infinity times x, and y equals infinity. I mean, that makes sense because y has got infinite values at 1x, which is 0. Now let's do something more interesting. Let us rotate this line downwards and let's see what happens. Here the y is actually negative and the x stays positive. So the ratio of y by x in this case is negative. So if let's say this is minus 1 and this is 1, then y is minus 1 times 1. And that is basically the equation of this line. Y equals minus x, right? Because y equals that ratio into x. And the ratio in this case is minus 1. So y equals that ratio into x. I've just called that ratio as w. And this w is so important and so popular in the entire field of algebra, trigonometry, calculus, that they have multiple names for this. So y equal to w into x. Basically w is the ratio, y by x. W is also written as dy by dx. It's also written as dou y by dou x. It's also written as delta y by delta x. All these have slightly different meanings, but we'll talk about more or less what they mean, which for our purpose of this video is just the simple ratio between the vertical and the horizontal. Now the next video is going to cover a new topic about circles. I'm going to connect that with what we just learned so far.